Hello, this is Nature Nerd 1000, and today I'm going to teach you how to write an ancient binary. So ancient binary is an alternative number system that has the potential to go base 22, but I decided to set it as base 21, and it's also compatible with base 12 and base 7 systems and all those systems, so it's called ancient binary. And you see, back in the day, the ancients created this system to be a 1 through 6 system. So the base code of ancient binary is basically this straight line with these three vertical lines, and then basically on the bottom it is odds, and on the top it is evens and odd numbers. So basically I'll just show you right here. So basically this is the set 1, 2, 3, 4, 5, 6. Okay? So basically what this means is, or this is 1. Basically if there was a line, there was just a line up here, it would be 2. 2. Then, as you can see, this is 3, so this is 3, 4, because then down here would be 5, and then down here would be, up here would be 6. Okay? So, in the ancient number system, basically it was a 1 through 6, but to add a 7, the ancients basically added a 0, a placeholder of 0, which is basically just a 0 in this ancient binary is just a straight line, because this was carved in rock, remember, so basically this is 0. So basically this is the original ancient binary code, 1 through 7. So basically if you wanted 7, then it would have been that. If you wanted 14, oh actually no, okay, I messed up. So 7 would basically be 1 set and 0, and then 8 be the same thing. So this is the original ancient binary, and this is called the Lucky 7 system. Okay, the Lucky 7 system. So basically, in the future, some brilliant scientists discovered that they could add more numbers. So basically, this is 6, and then this is 7, because this is 6 plus 1 equals 7. And then they discovered too 8. 3 plus 6, 9. So basically, they just kept going on like this. And so, for a while, there was a base 22 system, because this is the, because basically if you add all these numbers together, it can equal 21. 20, and then basically if you have the 0, like this, it's 22. So let's write that out. So 10, 4 and 6, 10. 11, 5 and 6, or actually, no, this 5 and the 6 equals 11. 12. Yeah, so let's write 12 and 13. 12 is basically 5 plus 6 plus 1. So basically this is 12. Now 13, it's just the 11 with a 1 up here. So 5, 6, 2. 14. So basically you just add it up, and you keep doing this, and I'll show you the standardized system, because you're thinking ancient binary. Well, how can this like be standardized. Well, it's standardized this way. So 15. So basically 16. This is 16. So basically now you have 11 plus 4 plus 1. So that's 16. Yeah, and basically you just keep moving over. So basically then this moves up to 2. And then this is 17. 2, 4, 6, 5. 17. Now I'll show you. Now 18. See? So basically the 2 is right here. So the next number would be a straight line. That's 18. And then basically 19. Okay, so now we move on to 20. Okay, I'll show you this. So as you can see, the 19, basically, so the plus 2, this would be 20. And then 21 is this. Okay, because this is 1 plus 2, 3, 4, 5, 6 equals 21. Okay? And so basically for a while, there was a base 22 system. Because basically, once after 21, then you would go like this, and then this is 22. And then this, you know, at the 0, and this would be 44, and then this would be 66. And basically this is how the ancient, or the binary system worked. Eventually it then progressed on. Now, eventually, ancient binary was simplified to a base 20 system to make it easier to count than base 22 systems. So what they did is they just limited this up to a 19, and then just after the 19, just cut it off. Although it has the potential to be a base 22 number system, the standardized now is this base 20. So 20, then 21, 20 plus 1, then this 40, 60, and this so on. It's similar to the Mayan number system. That's how this works. And I think 399 of this is the number before 400, and 399 would look like this. Okay, because basically this is 19. This is 19 sets of ones, and then this is 20 times 19, and then that basically equals 399. And so basically the next placeholder would be 400, and so 400 now basically looks like that, and then 401. 401. If you want to do something like 407, 407, then you want 7 sets of ones. So basically you do that, because this is 6 and this is 1. And then if you wanted 800, for example, 800, basically this is 2 times 400. And then you would just do that. 1200. 3 sets. Basically right there. Yep. And now, basically, if there was an extremely higher number, I haven't decided if it's going to be 2 or 3 yet. But, basically 8,000. Then the next number, basically, 400. Or, times 20 equals 8,000. So this would be 8,000. And then 16,000. It's similar to the Mayan thing. That's why I like it. And then it keeps going on to 160,000, where it reaches the next placeholder, where it reaches 5. So basically, if there's a lot of them, or for example, and let's say 5. So this is 160,000. Okay. So basically, in the ancient binary system, to do a continuous number, I haven't decided if it's either going to be a dot, like per 2, or per 3 probably. Or the other thing I did, I had to separate the like digits. You could change this to 2 or 3, but basically just like a vertical line, and this would symbolize that the numbers would just stay there, or I mean the numbers would just continue on, and it would be one connected number basically, if it looked like that, or if there was either a dot or just a straight line. This because this is carved in rock. Yep. So basically, in the world that I'm gonna create, hopefully someday, or in a book or something, basically I'm gonna use ancient binary definitely because I like the number system, like how it works and stuff. And ancient binary is also compatible. Let's write that. Ancient binary compatibility. And so ancient binary is compatible with basically anything between base 1 and base 22. So ancient binary could be used for a base 12 system, and this is what I think I'm going to use in my world personally. So base 12 system. What would a base 12 system look like? Well, basically 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See that. And then basically 11. And then basically after 11, this would be base 12. So then you would put a 1 like that, and then this is 12, and then 24. So yeah, I think personally I'm going to use a base 12 system if I was to create a magical land or something. Basically most countries would use that, but you could also do base 13, you could do base 12, you could do base 10. Let's write that. And basically it's just because you set the limits. You set the limit at 11 and then 12, or decdo L, and stuff. If you wanted a base 12 number system, like some people are like proposing right now. If you want a base 10 like our standard system, well, you just limit it to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 3, 4, 5, 6, 7, 8, 9, and then then 10, or you do 0. Let's add this too, because this single line is a 0 basically. So thank you for watching my ancient binary, my alternative number system. I hope you enjoyed the video, and yeah, it's Nature 1000 signing off. Bye everyone.